Hi, I'm Brooke, and I'm going to teach you how to implement selection sort. So selection sort is pretty straightforward. If we look at our example over here, we can see that we're keeping track of a couple of things. We're keeping track of the number of times we step through our list, and we are keeping track of our current index that we are comparing to. We're also keeping track of our minimum value. So for context, the way selection sort is that in our efforts to sort the list in ascending order, which means that the lowest values are going to be at the beginning and the highest values are going to be at the top, we are comparing the values. We are keeping track of our current minimum value, and we are comparing that with our current pointer that's going through the list. And since our minimum value might change, like we might find if the current array or current list is not sorted, then we are going to find different minimum values in here, and we are going to have to bring that to the very front. So in our efforts we can sort of see right here that our minimum value in this list, it's really easy to see that it's 2, in which case we are trying to find that value so we can eventually swap it with whatever's at our step right here. And that's at the very end. But we can see here that we're starting at I equals 0. We're starting by comparing 20 to 12, and then since we find that 12 is less than 20, our current minimum value resides at index 1. So this is now our current minimum value. Awesome. So then we go to I equals 1, we move that up again, and then we compare 12 to 10, and we find that our 10 is less than 12, so we have a new minimum value. Our minimum value is now at index 2. Okay, so we just move it up again. We compare 10 to 15. Minimum value is still at index 2 because 10 is less than 15. And here's the interesting part. We still want to move that one pointer up to compare. We don't want to change anything, the minimum value from index 2. We want to keep it at index 2 because this is our current minimum value. And then we compare that to whatever is at our next whatever's at our next value of comparison. Okay, easy. So in that case, we have reached the end of the list. We have found our minimum value, and we've set it at index 4. So now we can see at the very end, since we've reached it, once we break out of that loop, we are going to eventually swap whatever is at step 0, because we're going to need 2 loops in order to actually make this particular algorithm work. We're going to swap step 0, whatever's at 0, with whatever is at our minimum index, in which case it's the very end. It's not always the very end, but in which case it is. So we swap 2 and 20 to get the minimum value at the very beginning. And then in the next pass, we would set our step equal to 1, so this is now what we would be swapping with during our next pass at the very end. All right, cool. So how does that look in code? Well, the first thing we need to do is to define the function and take in an array of what is hopefully some integers. So what are a couple things we need to keep track of? We can set the length of the array just so we have it. What am I doing? Length of the array, just to make sure that we know that the length of the array is equal to whatever this is. And then we want 2 for loops. We're going to have 2 nested for loops. The first loop is going to be for keeping track of steps, so how many times we actually step through the list. So we can say for step, usually I would do I, but in our graphic we have right here, we have step. So for step in range of the length of the array, because we're going through until we reach the end, we want to also keep track of the minimum index. And this is important because we want to make sure that we initialize it at step. So our minimum value is currently whatever's at step, and then whatever's in J is going to be one more than step. And J is for our inner for loop. But first we have to actually keep track of the minimum value. I keep saying index, but it's the minimum value at the maximum index. So like the minimum value here was 10, and that's the maximum index with the minimum value at it. Anyway, we want to make sure we set that to step. Okay, now we need another variable to keep track of, which we can just call I. I said J before, but we're going to call it I because that's what said it. I'm getting I and J confused, but as we can see here, I is what we're going to be currently comparing our minimum value to. So let's go ahead and put an I in here. And it's going to be start at step +1, because every time we go, we have a new step, we want to initialize it right here at our new step, and then like right next to the step. So steps right here, I would be right here, steps right here, I'd be right here, etc. And then we would just also go through the length of the array. That's where we would stop. So what we're going to be comparing, what's going to be our conditional is essentially I, whatever's at I, and checking to see if it's less than the array at our minimum value, whatever the current minimum value is. So as we're going through each time we're increasing what I is, and then we are keeping track of our minimum value as well. So we're just going to literally compare to see if the whatever is at our current value at I is less than our current value at the minimum value. So yeah, we're going through, every time we increase I, we're comparing that to our variable that's held at as our minimum value. So then what we need to do is literally set our min value equal to I. Whenever we find the newest minimum value, if it's less than, if the current minimum value is less than whatever we find next, all we need to do is set it equal to that. We need to just reset it to the newest, smallest value. Great. So what happens when we get to the end? When we eventually get to the end of the array, we need to swap, right? We eventually get to the end of here, and we realize that we need to actually swap this value, our minimum value, with whatever's at step. So our step is 0, so we need to switch whatever's at, whatever is at step with whatever our current minimum value is. And we have to do that outside of the for loop, because once we break out, eventually we would swap, and then we would do a new step. So all we need to do is swap. So let's do array at step, and the array at min value is now equal to, we're just going to swap the both of them. And that should work. I don't know why I did that. That eventually swaps our step with our min value. So we set step to min value and min value to step, and that switches the two into its correct place. Then on the next pass, we would have our step equal to 1, and we would continue the process of going through and comparing, and eventually swap with whatever's at 1. Beautiful. And the last thing we need to do is, of course, return the array. And that's it. It's pretty simple. Let's go ahead and test it out. Let's put some values in here, like 3, 7. Perfect. All right, so when we run that, hopefully it will, and it works. We have a now sorted list with selection sort. And we didn't do anything wrong. So I hope this was a good understanding of selection sort. A good thing to keep in mind when thinking of selection sort, it gets very confused with insertion sort, which we'll do a later video on. But one way I like to keep them separate is to keep in mind that selection sort is selecting the minimum value. And if you can remember that is selecting the minimum value, hopefully that will be a good memory trick to know that it's talking about selection sort. So you can select the minimum value and then eventually bring it to the beginning, or put it into its place. Okay, I hope you found this explanation helpful. Let me know if I missed anything, and I'll see you next time. Thank you.